So in this video, we're going to review the individual gas laws that we have talked about so far and how to use those in a word problem. So a common concern I hear from students, particularly once we get all of our gas laws covered, a common complaint or concern I hear from students is that I never know when I should use which particular gas law. So this review should hopefully help you in determining what gas law to use when and how to best look at a problem and identify how it needs to be solved. So we've got three different problems here that are all going to focus on this particular gas, which has a volume of 250 milliliters at 25 Celsius and has a pressure of 550 millimeters of mercury. So just by reading that first sentence, I see that I have an initial volume, I have an initial temperature, which eventually we will have to put into Kelvin since all gas law problems use the Kelvin temperature scale, and we have an initial pressure, so we have a P1. So that's information that we have just from the first sentence of the problem. For the first bullet, if the gas is expanded to 450 milliliters, so we now have a new volume, so we have a second volume. So if the gas is expanded to this new volume, let's call V2, with temperature constant, what is its new pressure? So we're looking for P2. So I have P1, V1 with T constant. I have V2. I need to find P2. So the law that I need to use needs to involve just pressure and volume. And so that's going to be Boyle's Law. P1 V1 equals P2 V2. Now we're going to go on and solve that one as well as the other two, but let's just first talk through how we determine which gas law to use. So for this first question, we would use Boyle's Law to solve. P1 V1 equals P2 V2. For the second bullet, if the pressure remains constant, okay, so pressure constant, what temperature is needed? So I'm looking for a new temperature, T2. What new temperature is needed to increase the gas volume to 425 mils? So I have a new second volume. So in this second bullet, I've got a constant pressure, new temperature, new volume. So I need to think about which gas law involves volume and temperature. And that's going to be Gay-Lussac's law. V1 over T1 is equal to V2 over T2. Next, third and final one, which temperature, I'm sorry, Charles's law. This one is Charles's law. Third bullet point, which temperature is needed? So I'm looking for a temperature, so I'm looking for a new T2. What temperature is needed to increase the gas pressure to 1 atmosphere? So I've got a new pressure. So I have a P2. I have a P1 from my first information. I need to find a new temperature. I have the initial temperature. So I need to use the gas law that involves pressure and temperature. So that gas law is going to be Gay-Lussac's law, or P1 over T1 is equal to P2 over T2. Okay? So that's how I kind of read the problem and isolate what variables I am given, what variables I need to solve for, and then how I can determine which equation I need to use to solve. Now let's go ahead and solve those three problems. So let's do the first bullet point, which I have here. So I have written down from that same problem, initial pressure, initial volume, final volume. I need to find a final pressure. And so we said it's going to be P1 V1 is equal to P2 over V2. So to solve this equation for P2, hopefully you can see by now if I divide both sides by V2 to get P2 by itself, I'm left with P1 times V1 divided by V2. Now I'm at the point where I can plug and chug, plug in the measurements that I was given, the numerical value and the unit. And I can see that my milliliter units will cancel. And I'm left with a value that's going to be in millimeters of mercury, which is great because I'm looking for final pressure. So doing that multiplication and division should give you 306 millimeters of mercury. And that makes sense, right? We increased the volume, and Boyle's law says that when the volume increases, the pressure must decrease, which is exactly what happened. So that's one way that you can check your work with regards to Boyle's law. Next one, with Charles' law, we said that to solve that second bullet point, we were going to use Charles' law. So here's Charles' law, and here are those variables that I was given, and then the variable I need to solve for. I need to solve for the new temperature in Kelvin. And so I went ahead and took my initial temperature and converted it to Kelvin by adding 273 to it. So I'm going to take this equation, I'm going to take Charles' law, I'm going to solve it for V2, or I'm going to solve it for T2 by cross multiplying and dividing. And hopefully you see that the final answer is going to be T1 times V2 divided by V1. When I plug in my appropriate values, I see that my milliliter units cancel. I'm left with Kelvin, which is good. Temperature scale. So then doing your multiplication and division gives you a temperature that is in 507 Kelvin, which would be a perfectly acceptable answer for this problem. If this problem had asked you what the temperature in Celsius was needed to increase the gas volume, you would go ahead and still solve for Kelvin, but then you would subtract 273 from that to get the temperature in Celsius, which in this case would be 234. Okay. So that's how you do that second problem. Third and final problem with regards to Gay-Lussac's. So these are the variables that we were given. We need to solve for T2. But before we go on and start plugging in values or anything like that, what do you notice? Hopefully you notice that my pressures, I have an initial pressure, a final pressure, but hopefully you notice that my units of pressure are not the same. And for my units to cancel properly, I better have both of my pressures in the same units. So before I move on and solve this problem for T2, I need to go ahead and convert one of my pressures to the appropriate unit. So what I went ahead and converted my 550 millimeters of mercury to atmospheres using the conversion unit between millimeters of mercury and atmospheres that we talked about in the very first video for this chapter. Millimeters of unit cancel. So we now have a pressure in atmospheres in a unit that is the same as the unit for P2. So this is the value that we are going to use for P1 when solving our Gay-Lussac's law. We can go ahead and solve this equation P1 over T1 is equal to P2 over T2 by cross multiplying and dividing. T2 is going to be equal to T1 times P2 divided by P1. Then we put in our appropriate values. We see that the atmosphere units cancel and we're left with Kelvin. So then doing the appropriate mathematics, that gets you an answer of 412 Kelvin, which would be the same as 139 degrees Celsius. So I think these three problems are good representative problems of the kinds of gas law problems that you will encounter when talking about the individual gas laws.